Hello, welcome back. Now, let's think about a couple of other questions, right? We already know, since we all know that basically compounding. Oops, I'm sorry. I'll have to choose. I'll have to select this. Okay. So we know the compounding, right, is the very basic compounding formula is FV equals P times 1 plus R raised to N. And we've used an example of, let's say, making a deposit of 10K, and just to make it simple, keeping it there for 2 years. Okay, when interest rate is 10%, right? And we already know the answer. I mean, it's 12.1K, 12.1K. Let me write it. 12.1K, right? Now, then we can flip the question, or we can flip the question and see ask a question this way. So if I am entitled to a 12.1K 2 years from now, or if I want to receive 12.1K from 2 years from now, if the prevailing market interest rate is 10%, how much do I need to put into the bank today? Right? In other words, what should be my principal today? And we already know the answer. I mean, if interest rate is 2%, right, and you want 12.1K 2 years from now, then the answer is you have to put 10K in the bank now, right? But also, the principal should be 10. Also, the question can be rephrased this way. So then, if I'm going to receive 12.1K 2 years from now, I have some, let's say something, I have, an entitlement or claim to this 12.1K. And what gives you that entitlement? Something like, bond, right? You have a bond that matures in 2 years, and when it matures, it pays you 12.1K. It could be a bond or some kind of certificate, like CD, that entitles you to a claim to 12.1K 2 years from now. And so you have this bond or CD or some kind of commercial paper or investment instrument, right? That will mature in 2 years, giving you 12.1K. Now, you have but you are running into a cash flow problem right now. Currently, you are undergoing a cash flow problem. You're very tight with cash, right? So you have, but then it's not like you have nothing. You have 12.1K, but this is not today's 12.1K. It's gonna, you will have 12.1K 2 years from now, and you have a certificate that entitles you to that 2 years from now. So this is this CD or bond is worth something, right? It's worth 12.1K 2 years from now, but you don't know. Question is, you don't know how much it is worth today, because it will be 12.1K 2 years from now, but not just yet. But then, since it is at least worth something, if you sell it today, and if you cash it out today, then how much is it worth today? That will be another question, right? How much is it worth today, right? In other words, how much can you sell it for, and how much will the buyer, how much will the buyer pay? How much will is the buyer willing to pay? And the answer is, it is worth 10K today. Exactly. Why? Think about it. If a buyer is willing to pay something, and because if he buys it, he can hold it for 2 years until maturity, and he will get 12.1K. Then what's he gonna pay? Well, he will be paying exactly 10K, no more than 10K. No more than, he is willing to pay no more than 10K, and you're willing to accept no less than 10K. Why? Think about it. If he has a 10K today, he can put it in a bank or in a CD, because the prevailing market interest rate is 10%, 2 years from now, he will get exactly 12.1K. So why is he offering anything more than 10K? There's no reason for him to offer anything more than 10K. And just for the same reason, you are not willing to accept anything less than 10K, right? So this 10K is, of course, the principal of 12.1K today, if the interest rate is 10%. So mathematically, this is a question about solving for principal. And how do you solve for principal? Well, I've been telling you over and over, all equations are basically a question of whether you can identify or not the z equals x times y structure, right? And if you can identify this structure, what is x? How do you solve for x? X is then z divided by y, right? And also y equals z divided by x. Isn't that right? So it's really, all equations are basically a question of whether you are capable of identifying this structure. Once you identify this structure, then it's easy to solve. And no matter how complicated This one is very easy. It's very simple. This is z, this is x, this is y. So all you need to do is simply, so you're solving for p, then it is simply future value over 1 plus r raised to n. Okay? And this is called present value. Okay? In other words, principal is present value if you're looking at it from the future, right? If you're standing in the future and you look at the present, I mean, if you're looking at the present from future, the present is past, but from future's point of view, principal is called present value. Make sense? And see, no matter how complex, I mean, this is fairly easy and straightforward, right? And no matter how complicated, right? No matter how complicated, if you can identify the structure, right, you can solve any equation, right? Now, let me, that was too unnecessarily, the equal sign was too large. Okay, now, so in our example, all you need to do is, to find present value, all you need to do is divide 12.1 K by 1.1 raised to squared. I mean, I don't need the parenthesis here, okay, because it's obviously a number. And then you can use your calculator and I mean, Excel, your computer comes with a calculator, and I don't know if you can see this calculator. Let me try this. Stop sharing and let's see. Go back here and share application screen. Yeah, calculator. So you bring up your calculator, right? From we can do this on Excel, but I'm just trying to show you. You'll have to from your computer, right? From Start menu, you can pull up the, and you'll normally it is set to standard by default, but you want to select scientific, right? Because now then do this 12,100, right? 12.1 K. We divide it by 1.1. This is x raised to y, so on some calculators it may be that caret, the cone sign, right? You raise it to 2. Hit enter, you will get exactly 10,000. Okay? Did you get it? Alrighty, so let me go back to okay. Okay, that's what you see now. And we know what it's going to give you is 10K exactly. Now, so if you think about it, This is a reverse process of compounding, isn't that right? It's a reverse process of compounding. We started from compounding is basically, we started from compounding formula, and compounding is basically a process to find the future value. And the reverse process is the process to find the present value. And this process is called discounting. Okay, the process to find the present value, right? And the reverse process of compounding is called discounting. Now, also our next question is, suppose you have 10K today. We all know, I mean, this is the example we've been using. So without further, explanation, the assumption is that we have 10K today, and in 2 years, you want to have 12.1K for future value, right? Then think about it. What's missing? What is missing? What's missing? Isn't it the interest rate that's missing? Right? In other words, if you want to have $12.1K, and when you have 10K as principal, right? The question is, what should be the interest rate? What is missing here? What's missing is, again, interest rate, right? What's missing? So how do you find interest rate? So basically, we start from if you looking at the compounding formula, right? Looking at the compounding formula, right? It's the question about R, which is, the unknown in this case, right? And then, so solving for X, unknown X, but, the X is R here. So how do you solve for R? Now, here, we need a little more technique and a little more math knowledge, but whatever we can do, we should do whatever we can do, and what we can do is we need to turn it into a more simplified form. I mean, this is the simplest form, but what I'm saying is, since R is the unknown that we want to solve for, right? So let me do something. Let me do this. This is totally. We need to solve for R, we will need to isolate R. But is there any way we can isolate R directly from what it is now? No, there's no way you can isolate R. So we'll need to only, because R is part of this term in the parenthesis, and raised to nth power. You can isolate, the best you can isolate for now is just this term, right? You remember, this is like, solving, this is like solving this equation for y, because this is our y. Then 1 plus r raised to n is FV over P. Okay, so you're okay up to this point, but then our next question is, to isolate R, first we have to get rid of this exponent, right? It's almost like once this exponent is gone, then it's simple. If this is gone, then all you need to do is subtract 1 from both sides, and you can isolate only R. But the problem is, how do we open up this? It's like a exponent. It's like a padlock, and once you open the padlock, then it will be easy. Well, how do we do that? Huh? Okay, so to solve this problem, we need some understanding of basic algebra. Now, let's first think about the very basic example of exponent, right? So x squared, right? And x cubed. Now, first of all, we know if we take the square root of x squared, right, it will turn into x. We can lose, right? We can get rid of this, exponent. Now, another way to write x squared is actually, square root of x squared, x of x squared raised to half power. Okay, half power is another way of denoting, or meaning square root. Now, and if you remember from basic, algebra, right? Some rules of algebra, right? Right? X to the raised to a times x raised to b is x raised to a plus b, and x raised to a raised to b is x to a times b. Okay, now let's check. Probably when you took algebra, you probably simply memorized it, or just without too much critical thinking. Critical thinking always requires steps of verification, but without verification, you just memorize it by rote, and that's why it doesn't stick to you. That's why it doesn't last long time. you forget right after the semester is over. Now, let's try an example. Suppose you have 2 squared times 2 cubed, right? 2 to the 3rd power. What is that? It's 2 to the fifth power by this rule, but let's check. So 2 to the, we all know this is 4, right? So it's 4 times, and then this is 8, right? 4 times 8, 32. Which is exactly 2 to the 5th, right? Right, raised to 2 plus 3, right? Now then, this rule can be also easily verified. There are a couple of other rules, but we don't have time for that. We're going to revisit it later. Try the same thing. If you have 2 squared, this is what's wrong with. You have 2 squared, raise it to 3rd power. What's it going to be? It's 4 to the 3rd power, which is 4 times 4 times 4, right? It's 64, right? 14 times 4 squared, right? 16 times 4, right? 64, which is what? Which is exactly 2 to the 6th power, right? You can, verify easily, right? So this rule works. So, but then, think about it. By this rule, this becomes what? X raised to 2 times 1 over 2. 2 times 1 over 2 is 2 over 2, which is just 1. Which is x raised to 1, right? Which is x, right? So try that again with x to the 3rd power. Now, that means to turn it into x, we'll need to take the 3rd root or 3rd radical of x to the 3rd. 3rd radical or 3rd root or cubic root is written this way. Actually, square root is also original. It should be written this way. And means, is square root, right? This is the cubic root. Another way of writing it is x cubed raised to 1/3, right? If raising to half power is square root, raising to 3rd power is the 3rd root or cubic root. This is not very important, but I don't like it. And then, by the same process, right, becomes x itself, just right. So now let's generalize this. We know how that means if you raise if you have, I'm sorry, why is it so? X raised to n. If you want to turn it into x, you'll have to raise it to nth radical, 1 over, which is in other words nth radical, 1 over n. And through the same process, right? X raised to n times 1 over n, which will be exactly then x. Now, this is the properties of exponent that we need to solve for that problem. So, we'll talk about more about it in the next video. This is the end of the video, so I'll stop recording.